Here are the big three tests for the quadratic integrate and fire. The first one is for frequency, and you can see the important thing is to change the extraction points to 0.5. All right, instead of 1, because we're only going from -1 to 1. Simulation time should automatically be calculated. We're going to step the values of positive B, and we are going to use a pulse, and this will do an initial condition to set this capacitor to a known value. If you don't, the simulation takes forever. So we just start off at -1, we go up to B essentially forever, and then we measure the frequency. So we can just run that. Not doing it with that pulse, it took 15 minutes. All right, we can see our spikes, and then like before, view, spice error log, plot step data, period. All right, and 1 divided by that, and we get the frequency. And it goes from 30 to 90 hertz, which the oscilloscope should be able to do. It says it can auto scale at 25 hertz. So that's input voltage versus frequency. All right, now let's extract the switching threshold. Now I've already kind of found the times for which this works. Okay, and you can see where the input is changing. So we're going down to 0.25, so we should get a threshold voltage of 0.5. And this is where it keeps switching, and so we just have to look in that region, right? And we can see that this slope is 0 and then kind of goes high. So that's the region of interest. Now switching threshold is, it's got to kind of switch. So this one is going low, that one's going high, and so really it's right in between, and that is occurring at about 500 millivolts. And so our switching threshold is 500 millivolts, which is effectively 0.25 squared. So we have extracted the switching threshold when the input B goes down to negative 0.25. The final test is bistability. Okay, and you have to change the circuit. We're not extracting anything, so I left that the same way, but I'm actually doing a pulse from -1, or a triangle from -1 to 1, and I have some rise and fall times in a period, right? And we'll just run that. And what you see is that it starts switching, for a positive value of B, keep switching, and you can see a frequency change, but notice that it doesn't really stop switching till a negative value of B. So a positive value can turn it on, but a negative value is the only thing that can turn it off, and that's really a definition of bistability. And if this line were to represent the distance from a predator, right, it gets to a certain distance and the predator starts running, the prey starts running, right? And as soon as it gets away, it doesn't just get away a little bit, it gets away an extra bit, and then it stops running. So those are the three tests of the quadratic integrate and fire.